Hello. Good afternoon, everyone. Am I audible? If yes, then let us start. So, in this week, week 6, we will discuss some questions related to the some new marks beta gamma method, some central difference method, numerical methods, let us suppose. And in that, after that, we will discuss some questions related to the using the response spectra, find out the response of the structure uh, 2 3 questions for that, so total 7 questions we will be solving here. So we will solve it one by one, and that will be helpful for you as well in the solving the assignment of that question. So we will start uh, one by one. So first let me share my screen so that is my screen is visible.
Yes, sir. Visible.
Okay, so first let us discuss the basic questions, which is normally everyone knows, but here we will discuss somehow like what is the value of beta and gamma for the Newmark's beta gamma method if we have take the constant average acceleration on the linear acceleration method. So this might be you remember, but do you know how to calculate? So we will discuss it here. So first is like for the constant acceleration method. So in this constant acceleration, we assume our acceleration to be constant between a step from ti to ti plus 1. Okay. So for any step, let us suppose if our expression is like that, so we assume a constant value in between that. So let us suppose if here the value is u double dot I plus 1, here the value of u double dot I. So we assume a constant value which we will get as u double dot t at k time is the average 1 by 2 u double dot I plus u double dot I plus 1. So now we need to find out what is the displacement and what is the velocity corresponding to this to find out further next step. So for this, what we do the integrate for this equation with respect to 2. So integrate with respect to t. So if we integrate it both sides from ti to t. So if we integrate it, it will become u dot t from ti to t. It will become 1 by 2 ui double dot ui double dot I plus 1 t from ti to t. So I can write it as a u dot t minus u dot ti equal to 1 by 2 u double dot I plus u double dot I plus 1 into t minus ti. So u dot ti I can write it as a u dot I. Okay. So u dot t equal to becomes as a u dot I plus 1 by 2 u double dot I plus u double dot I plus 1 t minus ti. So one equation is this. Here the another equation, we need to integrate it again, and if we will integrate it again from both the side, we get it like this. Ut, I am writing the final equation, so we do not need to go to the whole procedure. U dot t is equal to ui plus u dot I into t minus ti plus 1 by 4 u double dot I plus u double dot I plus 1 t minus ti square. These are the two equations. So if I will simplify these equation, or either if I will compare it with the Newmark's beta gamma method, and then after comparing that I can find out what is the value of this. So for the Newmark's beta gamma method, uh, first let us write this as a for I plus 1 steps. So for the I plus 1 step, t is equal to for t plus 1 step or I plus 1 step. So if I will write it at ti plus 1, so that equation become u dot I plus 1 is equal to u dot I plus 1 by 2 u double dot I plus u double dot I plus 1, and then t is ti plus 1, and so I can write delta t as a ti plus 1 minus ti, so that becomes as a delta t. One is this, and the second is ui plus 1 is ui plus u dot I delta t plus 1 by 4 u double dot I plus u double dot I plus 1 into delta t square. So these are the two final equation from this 1 and 2. And from the Newmark's beta gamma method, I have the equation for u dot I plus 1 is u dot I plus 1 minus gamma delta t u double dot I plus gamma delta t into u dot I plus 1. So in this I can compare the first equation. If I will compare it from this equation to this equation, from this I will get my gamma would be 1 by 2. Okay, and for the ui plus 1, my equation for the Newmark's beta method is a ui plus u dot I delta t plus zero point 0.5 minus beta delta t square u double dot I plus beta into delta t square u double dot I plus 1. If I will compare this equation with this one, I can find out my beta is equal to 1 by 4. Okay, is there any doubt in this? Because this is a constant average acceleration. If sometime question may ask, if you consider it is a linear or parabolic, then you can find out what is the gamma and beta. So that's why I discuss it here. So any doubt in this? Okay, if not, then for the constant, next is the, this is for the constant. Now for the linear, for linear acceleration. So for the linear acceleration, what we consider our acceleration as a linear. Let us suppose it is at this point ui double dot, at this point u double dot I plus 1, and at this is it is the time period ti, at this is it is ti plus 1. So if I will write it at t, what will be my acceleration? And let us suppose the difference between this is given as a delta. ui double dot. So this equation is can be written as a this equation in terms of the t, u double dot t can be written as a delta u double dot I divided by delta t into t minus ti plus u double dot I, equation of this line, where delta t, as we have discussed earlier, that is the ti plus 1 minus ti. So if you will do it integral for the once integral for the integrated for the u dot t, and once you do for the ut. So if you do it, you will find out u dot t as a u dot I plus u double dot I t minus ti plus 1 by 2 delta u double dot I over delta t into t minus ti square, and for ut u dot, not dot, ui plus u dot I t minus ti plus u double dot I t minus ti square by 2 plus 1 by 6 del ui double dot over del t into t minus ti cube. If you both these two equation 1 and 2, if you compare with this one, the Newmark's beta gamma method, this one, and solving, put u double dot I as a your, put del u double dot I is your u double dot I plus 1 minus u dot double dot I. So from this, if after comparison, you will get gamma is equal to 1 by 2 and beta is equal to 1 by 6. This is simple calculation. You can do this. So for the linear acceleration method, we have the gamma is equal to 1 by 2 and the beta is equal to 1 by 6. For constant average acceleration, we have gamma is equal to 1 by 2 and beta is equal to 1 by 4. Okay, so let us move to the next question. If you have any doubt, you can ask here. Should I move to the next question? So in the next question, we have given an SDOF system which has mass has a 45,594 kilogram. Stiffness is given as 18 kilonewton per centimeter. Time period is given as a 1 second, means the omega in the 6.28 radian per second. Damping is the 0.055%. So we need to determine the response of the system for the defining the PT of the system in the half cycle pulse shown in the figure. In this figure, like this is a force vibration sine pulse fixed by using the central difference method with time step point 1. So the solution for this has been discussed thoroughly for the theoretically we have discussed the solution for this, like for the equation of mu double dot plus cu dot plus ku is equal to p naught sine pi t over td is discussed, or you can write it as a sine omega t. So these, for this the solution is discussed in the force vibration. You can find out the response as a ut as a if we let it down the for the free vibrate like for the undamped system, the solution was, what was the solution for the full cycle? That was something P naught sine omega t. What was the solution? Anyone remember? For the sine pulse, if we have the pulse sine pulse, what was the solution? Anyone remember this? Currently, I am also having problem like where I have put the solution. So the solution was for the P naught sine omega t, that ut was P naught by k into 1 upon 1 minus omega by omega n square into sine omega t minus omega by omega n sine omega nt. That was the solution for this. So here, if we don't have, if we have such a complex curve or something else, so we can find out solution through the numerical solution. So for the finding out the solution through the differential method, so the differential method is discussed in the class. So I will solve the example for that. The steps and how to solve these things has been discussed in the lecture. So let us discuss this one by one. So for the finding out the doing the central difference method, what are the things we required in the initial calculation. So for this we need to determine first u double dot naught. So that is determined as a p naught minus cu dot naught minus ku naught divided by m. One is that. Another is the u minus 1, which can be determined as a u naught minus delta t into u dot naught plus delta t square over 2 into u double dot naught k cap. We need to determine k cap as a m over delta t square. How these terms we got, that discussed during the class. I am not going to the whole procedure. I am going to the just calculation, so that will be refresh our concepts. Delta t square minus c over 2 delta t, and b is equal to k minus 2m over delta t square. So these things are which I need to calculate at a one time. I do not need to repeat it, calculate it again in the each step. These are calculated at once, so that will use in the all the steps. So take delta t is equal to zero point 0.1 second, okay, and the initial condition is given to you as a u naught 0 and u dot naught is equal to 0. So can you give me the values? So can you give me the, like, find out the values? What is my u naught? Anyone? P naught is also 0 initial step. At P naught is also 0. And in the question you can see what is mass. Let me write. Mass is 45594 kg. K is 18 kilonewton per centimeter. Damping is 0.5%. So first, find out what is the requirement. Can you give me the value of u naught? So for finding out the u naught, I have p naught, I have k, I have m, I have u dot naught, I have u naught, I don't have c. So c I can find out 2 xi m omega. Okay. So 2 xi is 0.05, m is how much? 45594. Omega is the tn is the 1, so omega is the 2 pi by tn. So can you give me the c? Anyone with the answer? Can you calculate the c?
It is 28.64
How much?
28.64 into 10 cube.
28.64 into 10 cube. Okay, here I am getting 28,584.9 Newton second meter. Yeah, there is some decimal place. Either everything is okay.
Psi is 0.07 or 0.5,
Zero 5%.
but in the previous line it shows 0.7 or 3.
No, the damping is the
No.
5%.
Okay, but in the representation what you have given, just above the calculation equation, go down. The red color one.
Oh, that is
It looks
like
like
it look like 7, so it is a 5.
okay.
So if you go to this C, now you can calculate the U double dot naught. Anyone with that answer? Initial calculations are necessary for the central difference method. So I have P naught as a 0. C I have that. U dot naught is 0. K is I have U dot 0 also 0. And M I have, so it will become 0. Okay. Same for U minus 1. Everything is 0. So it would become 0. Now can you give me the K cap? M is given 45594 divided by zero point 0.1 square plus C is 28,584.9 over 2 into zero point 0.1. Can you give me this? How much you are getting K cap? Then give me the A 45594 over zero point 0.1 square minus 28,584.9 over 2 into zero point 0.1. Same for B. For this K is given as 18 kilonewton centimeter. So that will become a 18 into 10 raised to power 5, which we call Newton per meter, minus 2m minus 2 into m is over 45594 over zero point 0.1 square. Okay. So can you give me those values? So that is coming 4702324.5 Newton per meter, or I can write it into the kilonewton per centimeter. So I will divide it by 10 raised to the power 5. So I am getting this as a 47.02 kilonewton per centimeter. For this, anyone with the A? 45594.
Double four, double four, 164.
Okay, so that is coming around 44.16 kilonewton per centimeter. And can you give me the later last one?
That is 7318800 minus.
So that will be coming out to be 7318 kilonewton per centimeter. Is it okay?
Yes. Yes. Okay.
So now I have the initial calculation. For the final calculation, for the calculation in the each steps, what do I need? I need pi cap, which is given as a pi minus a into ui minus 1 minus b into ui. Okay, and after calculating the pi cap, I can calculate my ui plus 1. For the, like, for the I plus 1 steps, I can calculate as a p cap I divided by k cap. So this I need to use. So what is my pi cap here? So pi is remain pi. A is I have 44.16 into ui minus 1, and b is minus 73.18, so it will become plus 73.18 into ui in terms of the kilonewton. Okay, so using this pi, I have k cap already, so I can calculate my ui plus 1 using that pi cap over 47.02 in centimeter. It will give me in the centimeter. So using this way, I can cal I can perform it in the each step. Okay, so now let us perform in the each step. How can we do that? So with this, like, let us suppose for the I is equal to 0. For I is equal to 0, 0, what is my ti? That would be 0. And what is my pi from this? So let us write the force value at the uh, if values. Initially I will write, so that will not be a problem. So at 0, it will be pi will be 0. Then it will be 25 at the point 1. It is 25. Okay, 8.2, it is 43.3. 8.3, it is 50. 8.4, it is 43.3. 8.5, it is 25. 8.6, it is 0. Then point 0.7, point 0.8, point 0.9, and 1. Up to this, it is 0, 0, 0, 0. And the steps are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now, can you tell me what is my ui minus 1? As you have formulation for the ui minus 1, ui minus 1 is 0 in the initial condition. As we have ui minus 1 is 0, so that will be the 0. So if my ui minus 1 is 0 and I is 0, so u0 is 0. So p cap, what will be the p cap? Pi is 0. In this, pi is 0. In this, pi is 0. ui plus ui minus 1 is 0. ui is 0. So what it become? Pi. Can you tell me what is the value of pi? Like p0? Anyone?
A cap 0.
It will be 0. P cap would be 0. If p cap is 0, then my ui plus 1 would be 0. Okay. Now, at the step 1, I is equal to 1. At I is equal to 1, what is my pi? P1 is 25. So, what is my ui? ui minus 1. So, if, let us suppose ui minus 1 mean at I is equal to 1, it would be my u0. Okay. So, at I is equal to 1, u0 is 0. You can take it u0 as, so that will come here. Okay. So, that is 0. So that is 0. And what is my u1? Can you tell me what is my u1? This is my u1 no? Because at I is equal to 0, my u1 is already 0 in the previous step, this one. So if you go through this, so that will be also 0. Now using these two things, this one, can you tell me what is my pi cap using this? This one is also 0, this one is also 0, but pi is 25. So that pi cap is the 25. 25. So now pi cap is 25. Then find out the ui plus 1, or ui plus 1 means u2. So that would be 25 divided by 47.02. That becomes as a 0.53. Okay. Now at step 2, u2 minus 1. So that would be u1. So u1 is, what is u1? This one, 0. This will come to the here. Okay. Then ui means u2, which is 0.53. I have calculated 0.53. Now using this 43.30, 0.53, can you calculate the pi cap? Anyone with the answer? Use this equation: pi minus 44.16, ui minus 1 plus 73.18. So can you give me the pi cap? Anyone can give me the pi cap value from this? Anyone?
82.0854.
Okay. So here we are getting P2 as a P2 cap as a 82.81, let us suppose. So I can get my u3, u2 plus 1. Can I get it? If you will calculate it, it will come out to be 1.748. Is it okay? Now can you tell me ui minus 1 for the third step? That would be the u2. What would be the u2 and what would be the u3 in this step? And what would be the P3 cap in this step? And what is a U4? Anyone? It is just simple. Nothing new in this. So can you give me the U2? That would be the same. Whatever is this one. So U2 is 0.53, and for U3 is whatever it is the same. That would be here. So that is 1.748. So using that, can you calculate it P3 cap? I am getting it as a 154.466, and then calculating U4 is coming out to be 3.284. Similarly, U3, U4, can you give a try? U5, in this case it would be U4, U5, U5, U6, U7, U6, U7, U7, U8, U8, U9, U9, U10, P5, P6, U5, U6, P7, U7, P8, U8, P9, U9, P10, U10. So can you give me the value? So U3 would be same in the previous step, that is the 1.748. Okay. U4, that would be the 3.284. So using that, if I will calculate P4, that would come out to be 206.5, and using that my U5 is coming out to be 4.39. Now my U4 is come out to be 3.284. So my U5 is the 4.39. So corresponding to that, my P5 is 201.32. So my U5 become as a 4.28.
That is U6.
Yes, that would be the no. Yes, that would be the I plus one. No, that would be U6, U7, U8, U9, U10, U11. So U6 is coming out to be 4.28. Now U5 is 4.39. So U6 is 4.28. So P6 is coming out to be 119 around zero point 0.4. So U7 is coming out to be 2.54. So U6 is 4.28. So U7 is 2.54. So the P7 is becomes as a minus 3.23. So my U8 becomes as a minus 0.0069. So my U7 become as a 2.54. U8 is minus 0.069. So the P8 become as a minus 117.16. So U9 become as a minus 2.5. So U8 become as a 0.069, that is minus 2.5. So P9 become as a minus 179, so that would become as a minus 3.8. So that you take minus 2.5 minus 3.8, so your P10 become as a minus 169, so that become minus 3.6. So this is the numerical value we have got. If we solve it theoretical, so theoretically we have the I have told you the solution. This one is the theoretical solution. Okay, do you have any doubt in the theoretical solution? Like that was what was that? That was the ut is equal to a cos omega t b sine omega t plus p naught by k into 1 over 1 minus omega by omega n square into sine omega t. Then apply the initial conditions, you will get your solution for this. This is for the undamped. For the damped, you need to multiply e raised to power minus xi omega n t, like that, for the free vibration kind of thing. So this, so the theoretical solution, I'm getting theoretical solution as a 0.91, 0.64, 1.8, 3.2, 4.23, 4.11, 2.56, 0.16, 2.15, 3.53. So here I can see the solution for the compare, can I can compare the theoretical and the numerical. So if I compare is this, so in this graph I can see like my peaks are coming nearly same for the theoretical as well as the numerical method, both the method. Only thing is that my peaks are shifting little bit, like from the 0.51 step it is like shifting. So that can be done by using smaller time step. Here we have used the zero point 0.1, so you can use it at 0.05 or 0.01, so then you can get a accurate solution for whatever it required. So is it okay? Okay, if okay, then we will move to the next question. So those will be the related to the next section. In the one was the numerical method and one was the response using the response spectra or something else. So in this question, these are the very simple questions. So there is nothing need to do so much calculation. So in this, we have given a small one-story RCC building frame is idealized as a massless frame supporting a total weight of 5,000. What is happening today? Okay, so the mass is 5,000 kilogram. Okay, at the each beam level, and the each column is given as a 25 by 25 centimeter size of the column, like the square column, and it is a hinge at the base. Okay, so we have given the E steel of the E is the 2 into 10 raised to power 5, 10 raised to power 20. Is it okay? Yeah, is it okay? So 20,000 MPa, and then we need to determine the peak response of the structure to a ground motion characterized by a design spectrum which is scaled to 0.25. Like whatever the response value we will get from this response spectra, this one we need to scale down it to zero point 0.5, 0.25. So we need to find out the response quantities are this at the displacement at the top. What is the displacement at the top? Okay, and then we need to find out the bending moment in the long column as well as the short column. Like we need to find out the what is the bending moment coming in this and what is the coming in this, both them. So let us do one by one. So I will give you the data. Like size of the column is given as a 0.25 meter by 0.25 meter. Okay, E is given to you as a 20,000 into 10 raised to power 6 MPa. L is given, L1 is given 3 meter, L2 is given 6 meter. Mass is given to you as a 5,000 kg. Okay, so first, to find out the response, we need to find out the stiffness and then time period. Corresponding to that time period, we will find out the response, and using that response, we will find out what is our displacement, what is the bending stress, or whatever the bending moment in the system. So can you find out the stiffness of the system? So for this, first find out the I, that will be the BD cube by 12. So that would be our 25, 25 power 4 divided by 12. So that is coming out to be 32,552.83 centimeter power 4. So can you give me the K, total K, K1 plus K2? Please give a try to find out the K.
It is 813.80 kilonewton per meter.
813.801 kilonewton per meter.
Yes,
Yes, correct. Any other? Anyone else? So that can be calculated as a K1. It is given as a 3EI by L1 cube plus 3I by L2 cube. So 3 into E is given as a 20,000 into 10 raised to power 6. I is given as a, we have calculated 32,552.8 into 1 over L1 cube is the 3 cube plus 1 over 6 cube. So if we solve this and divide it by 10 raised to power 8 to convert it into the meter, so we are getting it as 813,802.075 Newton meter. Okay. So can you give me the time period now? Anyone can give me the time period of the structure?
0.492.
So that is coming 0.4924 second. Okay. So now what I need to, one, I let me calculate omega n because that will be needed further. So that can be 2 pi by Tn. So that will coming out to be 12.75.
Hello.
Yes.
suppose if column weight is given, for example,
Yes,
then how can we do this TN natural period? Because in our assignment,
yes.
uh, they have given the mass per unit length per column, like a water tank. It's a water tank
Okay,
which is top on the column.
okay,
Is given mass of the tank plus uh, column weight also.
okay. So let me check what is the question. So I will come to the once. Let me check.
Okay, sir. Okay.
You are talking about question three.
Question number 4.
Okay, question is 3 meter long vertical cantilever made of 150 steel pipe supported 12 kg mass. Total of the pipe are 168 diameter. Second moment inertia, young modulus, damping ratio. So you need to find out the. So in this column, where is the written that you need to consider the column mass?
Damping the besides of damping ratio mass per unit length.
Okay, young modulus and the okay.
Even that suppose if second moment of inertia is there, right? I equal to 174 centimeter per 4. Suppose they have given outside diameter and inside diameter.
Yes.
If you calculate from outside and inside diameter, the moment of inertia is not same as it is given in I equal to 174. It's not equal to 174 actually. From the calculation of outside diameter and inside diameter, pi by 64, d power 4 minus small d power 4.
If you will calculate using the 150 meter inside diameter and the outside diameter is what is that? Let me check. 168.3. So you are saying it is not coming same. How much it is coming?
Let me check. Actually, I have calculated through calculator only. Uh, I Actually I calculated one rough paper only. That's why I don't have 1 minute. Is coming 117. Uh,
Yes.
and even he has given 150 tube. First line is given 150 tube, but in the middle it's given outside and inside diameter, two diameters.
Wait, 168.3. Okay, it is coming 117, and if you will consider it 150, then how much it is coming? 145. So you can consider whatever I is given to you. I think go with
But
that.
what suppose if it is hollow or solid?
That I is calculated like the overall.
No, not about I. Okay, I. Okay, no problem. But while calculating the regarding it is a solid column or a hollow column because 150 diameter is there, right?
Is
Uh,
150 is there, sir? It is hollow, not the solid.
because 150 meter steel is given. That's why I'm okay. Can we consider as a hollow? Right, right, right.
Yeah, you can consider the I whatever given to you 174.
Okay.
So that will,
Or if it is applicable for a diameter, suppose, for example,
yes,
like they are giving mass, right? Mass equal to kg per meter, right?
yes. If you calculate the mass, how much it will be coming out to be? Around
Mass,
80, 80 kg or something else, whatever it is.
yes, 84.57.
So how much time period it would be differ?
Uh, 1.1452 second. If you consider the column weight, full weight.
That is coming 1.14, and
Yes, yes.
without this is coming out to 1.107. Okay.
Okay.
So if you go with this, how
Uh,
much is the your A will change? Not much.
no, actually, I didn't calculate. There, I have stopped because this is not like a multiple choice question. That's why I could stop.
So that is not much difference you will get.
Okay.
So if you will calculate it, then you will get your like I think your answer will be nearly same, not much difference, because your time period is same, your A will be nearly same. So and that is within the range.
Okay.
So
The answer range. Okay.
so if you will calculate it, it will come out to be zero point 0.5, and if you will do that, then it is coming 0.495, something like that. So that range is given to you like that, so that your answer won't be wrong, I think.
Okay. Okay.
If you will ignore it, then it will be work.
If I ignore, okay, it will work, right?
Yeah, if you will consider it, then also it will be like good. So you can ignore it also, like as it's your choice, not let. So
Okay.
that's okay. And I will ask like the I you can post a question on the TA portal, because tomorrow is the last date, so they can
Yes.
post like what you need to consider regarding your I and that, so that they can answer you on that portal.
Okay, sir.
So you
Okay.
can write a question like regarding that I, like what should they consider. I think the whatever I is given to you, you can consider 171, but the outer diameter, and then what is the need for this if I is given to you. So that's okay.
Okay, sir.
So there is
Okay.
some, I think, conversion calculation problem from unit to unit. That's why it is coming different. Else is okay.
Yes. Yes, sir. Yes, sir. Okay, sir. Thank you.
Okay. So in this question, if we calculate omega n, it is coming out to be 12.75. So now after getting the omega n, can you give me the a corresponding to that t? Like t is coming out to be 0.4924. So from this graph, 0.4924 is in between this one, this range. Okay. So from here, my a by g is given as a 2.71. Is it okay, everyone?
Yes, yes, sir.
So that is given to you as a in terms of g, or it is given as a 2.71 g. Okay. So now what you need to do, you have to scale down.
Sir, that is A by G. Uh,
Yeah,
uh,
you can
yeah.
you can call it a in terms of 2.7 g. That is the thing,
Okay, okay.
unit in g. So we need to scale it to 0.25 as it is asked in the question. So we need to multiply it with the 0.25. So that is 0.25 into 2.71 g. And if I will take g as a 9.81, you will get a 6.646 meter per second square. So now you have A. Can you calculate the displacement? Peak displacement. So peak displacement is given by A by omega n square. So can you calculate that? Anyone?
That is 0.04 meter.
So that is 0.04 meter. So that will coming around to be 40.88 mm. Okay, that was the part A. Now in B, we need to calculate the bending moment in the shorter column. So the bending moment, how it is given, can be given 3 ei by L square into H into U naught, not the H. Did you understand how I write 3 I by L square?
Yes, yes.
If not, someone has any doubt, if you have a one end support, and if it is coming like that, so that moment is given as a 3 I by L square U naught. Okay, so that's why I write it.
Suppose if it is fixed, it means 6 by
Yes,
F.
yes, that would be 6 I. If that would be fixed, then it would be 6 ei by L square U naught, and here also that would be the 6 ei by L square U naught. Okay,
Sir, this direction you can change at the top.
yes, that would be changed, I think.
Otherwise, you have to put minus. Otherwise,
Ah, yeah, that
you
would
have to
be.
change the direction. Yeah.
So that would be like that, and that is like that. Is it okay? Is it okay?
Yes, sir. Yes, sir.
This is the direction.
Yes, sir.
So now using that, can you find out the M? So for this, 3 into 20,000 into 10 raised to power 6, I is given as a 32552.08 into U naught is a 0.04088 divided by 3 square. So can you give me? I am getting it as a 88.7 kilonewton meter. Is it okay?
Yes, yes,
So same do for the long column. So in this your L will be 6 meter. So that would be same. So that will coming out to be 22.17 kilonewton meter. Okay. Is it okay? Should we move to the next question? So our next question is a very simple question. It is a kind of derivation. Okay. So you can solve it. I will give you a hint. So in this, what is it is 7 that we have to derive a equation for the deformation, pseudo velocity, pseudo acceleration response spectra for a ground acceleration is given as a UG double dot. Like here the ground acceleration is given as a UG double dot T as a UG naught dot delta T. Okay, for the different we have to plot it for that xi is equal to 0 and xi is equal to zero point 0.1. So as we know, for the damped system we have the equation mu double dot cu dot plus ku is equal to minus m ug double dot t. That is our equation. So what if I will put it here, that value here, so that will become mu double dot plus cu dot plus ku is equal to, it will become as a minus m ug naught dot into delta t. Okay, so it is a delta t is a
So can you explain why this other side is minus, that ground motion acceleration?
did you remember our acceleration is always u plus ug naught, ug double dot plus ku is equal to 0. if
Okay.
if we have a, like, let us suppose a structure here, and if the ground, if we give the ground motion to the, or the excitation uz, okay, then the whatever the response it at u here, so for the acceleration term we will take as a total u plus ug dot double u double dot, and for the stiffness and the velocity we take only the relative, whatever the u, the displacement in the structure itself, u. Is it okay?
Yes, sir. Okay.
So that's
Okay,
why,
sir.
we taken this. So for the unit impulse, what was our solution? Because for the unit impulse, in the last classes we have discussed, for the unit impulse we have the solution ut for the damped system was the 1 over m omega n omega d e raised to power minus xi omega n t minus tau into sine omega dt. Okay, so here we don't have the unit, like that unit impulse delta, direct delta function is multiplied with this one. Okay, so I will replace it with this, so that will be delta t, like unit impulse delta t will become as a 1. So I is equal to m ug
This
dot delta t become as a m ug naught. Okay, so I can write it as a ut is equal to m minus m ug naught over m omega d into e raised to power minus xi omega and t minus tau into sine omega d t. Okay, so m will cancel out. So that ut become as a minus ug naught dot t omega d into e raised to power xi omega and t minus tau sine omega dt. So to find out the maximum response, my u dot t would be 0. So I can find out at what t, what is my maximum response. So if I do u dot t, this one, I am getting ug naught dot over omega d into e raised to power minus xi omega n. Actually, this you can replace it with the t, not the tau, directly. I do it 0, I'm getting it as a tan omega dt is equal to omega d by xi omega n. Okay, or I can write it as a 1 minus xi square over xi. Okay, so I'm getting t is equal to 1 minus 1 by omega d tan inverse 1 minus xi square over xi. Okay, so at this t value, my response ut would be maximum. Okay, so now in this response, I need to only the sine omega t value. So I, if I have the tan omega d t as a 1 minus xi square, what I can write sine omega dt. What would be my sine omega dt? Anyone? If I have tan omega dt is equal to 1 minus xi square over xi, what would be my sine omega dt?
Square root of 1 minus psi squared by square root of psi squared plus 1
No,
minus psi squared whole square.
that would be, uh, let us suppose if that is omega d t, then if it's 1 minus xi square, it is xi. So how much it is? Xi square plus 1 minus xi square. So that would be 1. So sine omega dt would be 1 minus xi square. Is it okay?
Okay.
So now if I will put into the maximum response, ut is equal to uz naught dot omega n 1 minus xi square into e minus xi omega n t, and sine omega t I can put it as a 1 minus xi square, and t I need to also, I can do it as a like this, so that will not be confusing. So exponential, what is exponential? Omega xi omega n, so that would be the xi omega n, and what is my t? That is 1 by omega d into tan inverse into 1 minus xi square over xi. Okay, into 1 minus xi square. Okay, further I can simplify it as a omega n. How, what can I write as omega n? Omega d by 1 minus xi square. Okay, so further I can simplify it as a ut uz naught, and that will cancel out, this one is cancel out with this one, so that is omega n exponential, and that will cancel out, omega d to omega d cancel out, so that will become as a minus xi over 1 minus xi square into tan inverse 1 minus xi square over xi. So that is my ut. Okay, so whatever ut, like maximum response is not the ut, it is a maximum response. So my d is the u naught So I can calculate the velocity response as a d by omega n or 2 pi by Tn into d. Acceleration response would be the 2 pi by Tn square into d. So for damping 0, what is my u naught or d is ug naught by omega n. Okay, directly it is this one. So that would become as a also ug naught over 2 pi by Tn, and then v would become as a ug naught directly, and a become as a 2 pi by Tn into ug naught. So these things you can plot with respect to anything. For damping point 1, if I will put damping as a point 1 in this equation, d become as a ug naught d by omega n exponential minus point 1, 1 minus point 1 square, tan inverse 1 minus point 1 square over point 1. So if I will calculate this, I am getting d as a 0.862 ug dot by omega n. D is this. So your v would become as a 0.862 ug naught, and your acceleration would become as a 0.860 ug naught into 2 pi by Tn. So these things you can plot with respect to variation of the Tn. So you can plot like d versus Tn, v versus Tn, a versus Tn. So in the first one, if you will plot u naught, so that will be some that kind of line. In the second one, that will be the straight line. Okay, and in the third one, that is the divided by Tn, so that would be like this one, not this one properly. So that would be this one. Similarly, in the next one for J is equal to point 1, your it would become as a that line that will be decrease like that. Okay, for this it will decrease like this, and for this it will decrease like this. Is it okay? Any doubt? Should we move to the next question? If not, yes, someone has any doubt? Okay, let us move to the next question. So next question is very simple. You can do it by yourself also. You have given a single degree of freedom system which has a weight of 25 kilonewton. Its natural frequency or the natural time period is given to you 1.5 second or 1.6 second. So peak deformation is also given to you 127. So can you find out the pseudo velocity and the pseudo static force, like the peak equivalent force? Can you give a try? Like it's just very simple. You have the time period, you have the weight. Using that, you can find out the stiffness. Okay, if you have the stiffness, so deformation is given to you 127. So velocity you can find out. Multiply with the no, not multiply, divided by the omega n. So you can find out omega n is equal to 2 pi by Tn, and then the equivalent static force you can find out as a k into u naught, and u naught is given to you as a 127. K you can find out. So give it like you can do it calculation. Please do it fast. Fast. There is nothing in this question. So what is my omega n? Anyone?
3.951.
So that is coming 3.95 radian per second. And what is my mass? That would be W by Z, 25 into 1000 divided by 9.81. So that will be coming out to be 2548.42 kilogram. So can you give me the stiffness of the system? Stiffness can be given as a m omega n square. So m is 2 pi 2548.42. Omega is 3.95 square. What is my stiffness? Anyone?
39761.7.
Yes. Th- This is coming 3976 kilonewton per meter.
1.7.
Okay. So K is there. So now what we need to first pseudo velocity V. So V can we find out as a omega n times V. So the omega n is that 3.95 into D is 127. So that will be coming around to be 501.65 mm per second, or you can write it in zero point 0.5 meter per second. Another part is the static force, that will be F into K into U naught. K is 39.76 into U naught is our 127. So that is the 0.127. So that is coming out to be around 5.05 kilonewton. This is a very simple question. So now we have the two long questions. So I need your assistance from your calculations. So first, please note down the whatever data is given. So here, what is given? We have a water tank actually. So we have three cases. In one case, we have increased the stiffness. Okay. In one case, we have the increase the stiffness as well as the mass. So using those all three cases, we need to find out the response. Like what is the peak response? What is the maximum shear force or shear force, or whatever the static force, base shear. And then we need to compare, like what can be like in the water tank, what is the effect of increasing the mass or increasing the stiffness. If the time period is same, then the what is the another factor will affect that. So those things we need to discuss. So you have given a water tank of 25-meter height. Okay. And it is idealized as a single degree of freedom system with a mass of 50,000 kilogram, with a lateral stiffness is given to you 700 kilonewton per meter, and damping ratio is given to you 5%. So the for the damping 5%, we have given the curve itself. So the lower tower supported the tank is to be designed for the ground motion characterized by the design spectrum, which is given in this figure in this question itself. So which is scaled as a 0.5 g, that is remain same. So we need to find out the design value of lateral deformation and the base shear. One thing. In the second part, we have like we decided to stiffen the tower by increasing the size. So by increasing the size, the design value of deformation, the base shear would be modified if the lateral stiffness of the system is 1400 kilonewton per meter, and the damping is remain still same. So we need to comment like how the stiffness of the system affect the design requirement. Now another is that if the stiffness of the tower is like as a were to support a tank with a mass of 10,000 kilonewton, 100 yeah, that is the 1 lakh kilogram around. So we need to determine the design requirement of the damping ratio 5%. So we need to comment how the weight will affect our design requirements. Okay, so let us go one by one. It will be like a shorter exercise. Not only thing is it is a longer. but nothing is the conceptual more. So in part A, we have given mass given as a 50,000 kilogram, stiffness is given as a 700 kilonewton per meter, damping is given as a 0.5%, 0.5% or 5%, it is 5%, no. Damping is 0.05. So can you give me the time period of the system so that we can find out the u naught? Anyone?
1.679.
So that is coming out to be 1.679 second. So corresponding to the 1.1.6, what should be our x from this? What is our a? So I think it is not visible to you. So let me try if I can zoom it. Now it is visible. So that is this one 1.8. So your a is given as a 1.8180 multiply with the Tn inverse. So in G, so that is 1.80 divided by Tn is how much? 1.679. So that will coming out to be 1.072 G. Okay, so we need to scale to zero point 0.5 G.
But actually, it is not straight line, right? It's an inclined line. Then we have to find, right?
Yes, that is given corresponding to that 1.6. We have given this inclined line. So
No,
the
no. Suppose, for example,
yes,
suppose we get two. For example, time period is two. For
yes,
example,
yes.
then how? What is the value?
That
Then
would be the 1.8 multiplied with the Tn inverse, like divided by Tn. So Tn is 2, so
okay,
that would be
okay.
zero point 0.9.
Yeah, yeah, understood. Okay.
So we need to scale it down so we can multiply it with the zero point 0.5. So that is 1.072 into zero point 0.5. So that is coming out to be 0.536 G. Okay. So our acceleration SA is coming out to be 0.536 into 9.81, coming out to be 5.258 meter per second square. So the maximum lateral deformation is given as a d over SA by omega n square. So omega n can be calculated from here, 2 pi by Tn. So that will be 2 pi by 1.679. So that is coming around as a 3.74. Okay. So if I will put it here, 5.258 divided by 3.74 square. So I am getting d as a 0.3755 meter, or I can write it as a 375.53 mm is the d. So base here I can determine f into d, I can write it as a u naught also. So k into u naught. So k is given me to as a 700 and u naught is given as a 0.3755. So what is my base here? That is become as a 262.85 kilonewton. So that is the part A. So in part B, what change we have done? We have, with mass is the same 50,000 kg. Okay, mass is same, only the stiffness is doubled. So that is the 1400 kilonewton per meter. So can you find out the Tn, omega n, A, then D, and then F base here, so that we can discuss. Can you give me the Tn?
It is 1.187.
It is 1.1874. Okay, so omega n is coming out. How much omega n?
It is 5.29.
So that is coming out to be 5.29 radian per second. So corresponding to 1.18, that will also your same 1.8 divided by Tn, and that you need to multiply with the, for the scale down, zero point 0.5, okay, into G, 9.81. So can you give me the value of A?
– 7.435.
Yes. So it is coming out to be 7.435 meter per second square. So now I can calculate the D, which will be A by omega n square. So how much D I am getting? 7.435 divided by omega n is the 5.29 square. So I am getting it as a 0.2655 meter, or 265.5 mm. So what is my base here? So my base here is coming out to be 371.8 kilonewton. That is okay. After doing this, in the part C,
It is increasing, right? Base shear.
yes, that is increasing. We will discuss it in the end, like comparing both the part, all the parts.
Okay. Okay.
So in this, what have done? Like mass is doubled. So mass is 100,000 kg. Stiffness is same 1400.
No, 700.
No, no. Like after the part two, now we are doing the that case.
Then we can't compare, right?
No, that is like after increasing the stiffness. Like what is the mass? Like what is the base here? Like read the question properly. If the stiffened tower,
Okay. Okay.
okay.
Okay.
So K is given 1400 kilogram kilonewton per meter. So if we calculate, because that is increasing the same ratio, the time period is coming out to be same as coming in the first case, 1.679. Second, omega n is also coming same, 3.742 radian per second. Okay, so your SA by G would be coming out to be same, so that your A final or the SA is coming out to be 0.536 after the scale down, so that will become as a 5.258 meter per second square. So our D would be same. So D would be 0.375.5, sorry, 5 is equal to 375.5 mm. So now the base shear K into U naught. So that would be the 14 into 0.375. So that is coming out to 525.7 kilogram. So let us compare part, mass, stiffness, Tn, D, and base shear in kilonewton, in mm, in second. Okay, so in A, B, C. In A, my mass was the 50,000. In B also my mass was 50,000. In C my mass become 100,000. In this my stiffness was 700. In this it becomes 1400. In which it becomes 1400. So in this that coming out to be 1.679. In this my time period is decrease 1.1874, and in this it is same 1.679. D is coming out 375 mm, 265 mm, 375 mm. So base year 263, it is 372, and it is 526. So we can compare, like, if we stiffen our system, what happen? Our time period will decrease. At the same time, our peak displacement is decreased, but at the same time our base year is increases. Okay, and in the next case, if I increase the mass, then my time period will remain same and the displacement is remain same, but also the base year is also increasing. So that as I increase the stiffness, my base year is also increasing. That is the like the common thing. Like if my system is very stiff, my base year is very high.
Uh, so base shear is what is the importance of base shear? Means if you suppose 263 base shear is there, part C,
Yes.
part B. Here 372, right? Uh, we want more base shear or less? Means
Like this is our actually demand corresponding to, like, this is capacity of the system, base year.
okay, base shear means capacity. Okay.
We can, like, we have the given stiffness, we have the given mass. So how much like the capacity of the our tower has,
Okay.
that
Sir, we
is the.
can call it demand. Demand is better word actually. When we design, we can call it capacity.
No, no, no.
If you if the BDQ but 12 or something when we design, no, that time we can call it capacity. This time it will be demand. This much demand will be there on the structure.
Okay, this much is the demand for the particular earthquake, like for that we
Yes,
can
yes,
say.
yes, yes. Demand actually.
So our structure should like the resist that much of the base year.
Okay.
Yes.
Here, base shear means how can we call it as a demand? Because it is all depends on properties, right? K and
No, no.
L. Ah,
This much for this much it has to be designed. So it is a demand. So you cannot design for less than this because you already considered the scaling factor, no? So you are considering the design value, base share. It is actually
Yes, that should be design base year.
this is a design base share. It's a requirement. It's a demand actually. For this, you have to design the stiffness of the element, column, or
Yes, we
structure.
need to define the size of the section on that basis of
Yes,
that
yes.
demand,
Based on this demand, you have to
based on this demand.
satisfy this demand actually.
Yes.
no, no, no. I didn't have a clarity. Please, one. Please, I
No
have
problem. No problem.
clarity. Okay, here base shear I'm getting 263. Okay,
Yeah.
for part A, and part for part B it is coming 372, right? Suppose if
Yes.
I want to design a support,
Uh,
suppose fixed support, for example. Here
okay.
for part A is 263 kilo. For I have to design for 263 kilonewton, right?
No, no, no. You have to understand that, what happens is when you define the stiffness of the column member or water tank, let us say the column, if a single column, if you design, that time, the more you make it rigid, the more forces it will attract. So you have to make it more flexible, make it little bit flexible. Then the forces, base shear will be less actually. The more you make rigid, the more forces it will attract, seismic forces.
You can understand it through the isolation system. What we do in the isolation system, we reduce the time period. We increase the time period of the system so that our seismic force, seismic demand reduces. So
Okay.
if our time
Yes.
period is higher, then our demand would be like our seismic demand would be lower. So our section size will also be reduced.
Then here we can say for part B,
Yes,
372 means it needs to be designed for 372 kilonewton. Demand, right? It is demand.
yes, yes, yes,
Demand means we have to satisfy that 372 kilonewton force.
yes. Like
That means
our system.
for higher base shear, that means we can say that it is less efficient. Can we
Yes,
say like
yes,
that?
yes, yes, yes.
Okay, here part A is efficient. Can we say like that?
Part A is only applicable up to 263. Like, yeah, it is better than like A because it has the lesser base year.
Yes, yes,
Part A has the time period is higher because it
yes,
required the seismic demand is reduced. You can say
yes, yes. Because 2 days back only I have written this. I have read the article regarding this base shear. I didn't understand there. Base shear is increasing. Actually, that here we are increasing the stiffness.
yes.
Even though when if you increase the stiffness also, why we are getting more demand? That is my doubt. Here, there,
Your
A
time
is
period. If you go to the response spectra, when
okay.
your stiffness is higher, that mean you are in the like your seismic demand would be higher. SA by G would be higher for the lower time period.
Yes. Yes. Yes.
If you go through the response spectra from the
No,
IS,
even this sketch, sir, you can show the sketch above
yeah,
also.
in this also,
And the above sketch also
in
same
this
pattern
also,
actually.
like for the lesser time period, your acceleration would be higher demand.
Okay, lesser.
This one.
Below 1 second, below 1 to 0.1 second, between this range it will be
Okay,
0.66 to 1/8 second. Within this range it should be.
So as the our time period is increases, our
okay,
seismic demand is also reduces.
okay, okay. That's what I'm asking. Here we are increasing the stiffness.
Yes.
Even if you increase the stiffness, means we are we are giving more dimension. Okay, then that means okay, seismic.
For the seismic perspective view, we are
Base
talking.
shear will increase. Base
Yeah.
shear will increase.
Yes, yes. Understand.
In the actually what happen if our like mass is higher over actually then what happens, our acceleration would be lesser,
Yes,
and if mass is lesser then our acceleration would be lesser. So here that in the third case also you can see like time period is okay, but our base year is high with the time period is increasing. I don't know what I'm saying actually.
okay.
No, when the
Maybe.
mass is increasing, the force will increase because mass into acceleration. No? When you
Yes,
increase the mass, automatically the force F equal to
force
ma,
will be increasing.
automatically it increases. Yes, simply it will be like that.
Yes,
uh,
Direct.
I would like to finally conclude one thing.
Mm.
Suppose if you increase the stiffness
yes.
without increasing the mass, we can say design base shear means sorry, base shear will increase. Can we say like that?
Whenever you increase the stiffness, the base shear increases.
Okay, then can I say like whenever we don't want to increase stiffness, but if I want to increase mass without
Yes,
changing any stiffness, like
yes,
part C,
Yeah.
can we say base shear will reduce?
No, no, no. When you increase the mass, the base shear will increase.
Okay, that means
Whenever more mass is there, the base shear will also increase
that
directly.
okay, that means we if you increase the stiffness or if you increase the mass, it will the
Base
base
shear
shear
will
will
increase.
increase, right?
Increase. The only way to reduce the base shear is to make it flexible. The
No,
system flexible. Then only the base shear will come down.
no, because here,
For the same mass, if you want to bring down the base shear, you
okay,
have to reduce the stiffness.
I think he has doubt. Like he was saying, like if we have a case with a
yes,
100,000 and we have the stiffness as a 7,700. He's
yes.
saying. So in
Ah,
that case,
Hmm.
our time period will also increase.
yes.
That will be, let us say, around 2 seconds. Okay.
Okay,
In that case, what happens? My base shear will reduce. Okay, but at the same time, my peak displacement is increasing.
okay.
Sir, we can directly take omega is proportional directly to k by m, no? So directly when you increase the mass, the frequency comes down. So that means it becomes more stiffer.
No, no, that is the flexible, no.
K becomes less, no? K becomes
K become
less stiffer. They become
less,
flexible.
then
It becomes flexible.
it is flexible. Then your base shear is
Flexible,
also
yes.
lesser. But in that case, your like D would be like around 500, something like that. Let us suppose that would be higher. So that is also, we have some certain limit of that. Like our D should not be higher. That those are also limitations. Like to reduce, then we can do, in that case we can increase the damping.
These
That's a
displacement are at the top, you mean? Sir,
Yeah,
these
yes,
displacements are at the
yes,
top, no?
yes, yes.
Okay, okay.
At the top,
Yeah, yeah, correct, correct.
displacement will increase anyway.
Okay.
okay. That is okay, but I'm only focused on this base shear only.
Yes.
Like when you increase mass, also you have written base shear is reducing in the last.
Base year will actually that will increase with the increase in the, actually in this case what happen, our stiffness is remaining same while increasing the mass from this. So over what happen, our D is increasing, so that's why our base year is increasing.
Okay, okay. Okay, then I
So,
will.
those both the things are comparable. Like you cannot say, like if I increase the mass, then at the same time you need to look into the stiffness also. Like what is happening with your stiffness, that thing you
Okay.
also look into this.
Can we optimize this thing like base shear? I would but the main thing for a design,
Yes,
we have to have a less demand, right?
yes, less demand.
For that, can we optimize like this, like those things, mass and K? Uh, what could be
Mass
the
is generally you will not be able to change actually. Stiffness only you will be because the loads are given by other disciplines. You cannot change them. Mostly you don't have control over the mass. Only stiffness you will have control because that is free for the structural engineer.
okay, okay,
Structural engineer is not allowed to reduce the mass and all because the weights are given by other people based on their requirements actually. Generally, you don't touch the mass actually. You work on the stiffness. Stiffness, whatever, it's fully in your hand. Which B, D, whatever width and depth you can provide for the structural member. Only that is in your control.
Sir, more flexible system will deflect more, sir.
What happen?
More flexible.
Means system is flexible, then it will means deflect more, means displacement may
Yes.
be out of control, na?
So that's why we increase the damping. That is the another scenario. You can use higher
Okay.
damping. As you will increase the time period, your demand will reduce. But at the same time, if you will reduce the time period, let us make a curve, like for the this one, SA by G curve. So from this time to this T1 to T2, if you go, your demand is decreasing, like SA1 to SA2 if you go. But at the same time, if you will make a displacement curve for this displacement response spectra, then this will go out this. So for this T1, so for T1 to T2, your displacement is increasing, not like this. This will be, I think, this way. This should be like that something. So your displacement is increasing. So to reduce this, T1 to T2, your D1, D2. So reduce this. If we increase the damping, Xi, so our displacement will come into the control like that. So that is the principle of seismic isolation on all. So that is our last
Okay,
chapter. We will
sir.
discuss on that.
Okay, sir. It is clear now.
Yes, yes, clear.
Okay. So now we have a last question. So in the last question, we have given a structure like that is the same kind of example you have done on your first assignment, I think also. Like you have a story supported on the four column. A rigid slab is there, and there's those four columns are clamped on the foundation. Okay. So you have given uh, the response spectra for this corresponding to that like ground motion. So we need to find out like what is the uh, displacement at the top of the column, and what is the value of the torque, and what is the movement in the column is coming out to be this. So we need to find out the these three things: displacement at the each corner of the roof slab, torque, and the bending moment about the x and y axis at the base of the each column. So for this, first we need to find out what is our equation for this system. I think you have done that that you have done in the first assignment to solve the equation. Did you made it? Anyone?
This was solved actually in the. It is there in the solutions.
So it is there in the solution for the like for the stiffness and the omega, and you can use.
Yes, yes, yes.
So
It
using those
is.
things, we can find out the uh, response. So here I can directly write the equation. So that equation was that for this system. So that equation was the I naught UG double dot, not UG, U theta plus K theta U theta is equal to minus I into UG naught double dot. Okay, so I naught for this, if your plate has this B, this T, so that will be M by 12 into B square by B square plus T square. Okay, and K theta for this system is given as a uh, kx kx into d square plus ky into b square. This is like these are solved in the example of AK Chopra. If you follow this example of 2.4, in which they have find out the k theta, omega n, tn, and the equation. This equation is made up of example 1.7 in the AK Chopra. Okay, so now we have given the b is equal to 9 meter, D is equal to 6 meter, H is equal to 4 meter. Okay, mass is given as a 500 kilogram per meter square. Okay, Kx is given as a 300 kilonewton per meter. Ky is given as a 200 kilonewton per meter. Okay, so we need to first find out the k theta and I naught, so that we can find out the time period 2 pi by I naught by k theta. Okay, that is our time period. Corresponding to that, we can find out a. Corresponding to that, we can find out our displacement, what is our displacement, and then everything will go into like u theta. We can after finding out the u theta, we can solve it fully. So let us go one by one. So I naught is m is given as a 500 kilogram per meter square. So m is the 500, b how much is the 9, d how much 6 by 12 into 9 square plus 6 square. Can you give me the value for the I naught? K theta is the kx is the 300 and d is the 6 square plus 200 is the 9 square, and give me this value as well and calculate the time period. Anyone with the value of k theta and I naught?
263250.
So that I naught is coming out to be 26353250 kilogram meter square. Okay, and k theta, if you will calculate, it will coming out to be 27,000 approx kilonewton meter per radian. Okay, so if you will do this, 2 pi I naught is 263250, and that is 27,000 into 10 raised to power 3. Okay, so that will be coming around to be 0.62 second. Okay, and if you will calculate omega n, so that will be coming out to be 2 pi by tn, so that will be coming out to be 10.12 radian per second. Okay, now corresponding to 0.62, we can find out what is our acceleration. So here, that is lying in this range, that is constant 2.71.
One is there for 1 second is there for 10 second is there, right?
No, these are the bottom is the logarithmic. So that
Yeah.
is converted, time period is 1 by 8.25, not 0.25, 0.15. 1 by 8 is 0.15 or something. What is that? 0.125 to 0.6 is we have given the 2.71.
Okay. Okay.
The bottom one is not that. The natural time period, the bottom one scale is the some logarithmic scale. It is not that one. That is the same, I think. That is some
Okay.
different thing.
Okay. We have to see that 1/8 and
Yeah,
0.
that is clearly written. You can check in this also, but that we don't have the scale value, so you can whatever given in the box using those as a, you can take as a reference.
Okay. Okay. Thank you.
So your A is coming out to be 2.71 G. So we need to scale it to how much we need to scale? We need to scale 0.05. Okay, so we need to do it to 0.05. So it is coming out to be 0.1335 G. Okay, so the design spectrum, they are saying like this is a given in terms of the A, so they are converting it to be like they are saying like the B by 2 into ug double dot ug naught is given as a they are saying this one design spectrum. Okay, so we can find out, because this is given in the question itself, like the design translational ground acceleration is given as a b by 2 ug theta double dot. So ug theta, so from this ug theta you can find out a into 2 over b. So ug theta, only ug theta you can find out as a 2 by b into a by omega n square. Okay, so let us find 2 b is the 9 meter, a is 0.1335 into 9.81, omega is 10.12. Okay, so if you find out this one, so ug theta is coming out to be 0.00288 radian per second. Okay, now we need to find out the displacement at each corner. So we have find out this one, this u theta, u u theta of this slab. Okay, so if you remember in the when you draw the solve this in the first assignment, you have find when you give a initial rotation u theta is equal to 1. So how much force, let us suppose it is b, let us t, so how much force it is, it will be having, let us suppose it is b by 2, so this will also come b by 2, so it is coming out to be b by 2 into u theta, okay, this way, and that will coming out to be d by 2 u theta. In each column, this is the way the force is coming, b by 2 u theta and d by 2 u theta, then same d by 2 u theta, b by 2 u theta, b by 2 u theta, and then it will be coming d by 2 u theta. So at each column the deformation is coming out to be d by 2 u theta and b by 2 u theta. So find out that, so that would be b by 2 u theta is a 9 by 2 into 0.00288. So that will be coming out to be 0.0129 meter, and d by 2 u theta is coming out to be 6 by 2, 0.00288. So that will be coming out to be 0.00865 meter. So that is the displacement. Now we need to find out the torque. So that would be k theta into u theta. Okay. So the k theta would be how much k theta? We have calculated k theta. This one, 27,000. So that is the 27,000 kilonewton meter radian into u theta is the 0.0288 radian. So that will be coming out to be 77.8 kilonewton meter. Okay. Now we determine the bending moment. Bending moment at the base, or whatever it is will be same at the base and top. Okay. So for this we first need to find out the what is the force is coming on that, fsx and ftx. So fsx would be k theta d by 2 into u theta. So k theta is your 27,000, d by 2 is your 6 by 3, 6 by 2, and that is the 0.00288. So that is coming 2.6 kilonewton. Similarly, fsy is k, that will be kx and ky, and that kx is given as a 300. Ky b by 2 u theta, so that is 200 into 9 by 2 into 0.00288. So that would be your 2.6. That is also same. So if you have fsx, can you find moment? Can I find out moment as a 1 by 2 fsx into h? Is it okay, or do I need to explain this?
Yes,
Do I need to explain this?
not required.
Okay, but let me explain if someone is not known. If I have a fixed clamp and that is moves with certain like that, so in that case, is it sign convention is okay? I think okay. So there is
Okay, sir.
some, what is it okay?
Okay, sir.
So that was the moment was the we write it as a 6 ei by l square into displacement, 6 ei by L square into displacement. So what is my reaction at that point? R. So if I R calculate, that coming out to it 12 EI by L cube into delta. That is, so that is the whatever I have calculated Fs and R. So my movement would be the half. That's why I divided by 2. Fsx divided by 2 and multiply with the height. So that will give me the moment. Is it okay? Then you can calculate Fsx into 2.6 into 4. So that is 5.2 kilonewton meter. Same for the my direction. Fsy by 2 into h. That is also same 5.2 kilonewton meter. Is it okay? Any doubt? Any doubt in this question? Anyone? Or in all 7 questions if you have any doubt? I think this assignment is also very easy. I think only these things. You need to find out the time period, finding out corresponding to the spectral acceleration, find out the peak response, and then the BSCR. And then if some of the question though they ask also the bending stress. So that is the same. Anything? Or should I conclude the session? If not, if you haven't any doubt, you can leave the session.
Thank you so much, sir.
Okay, thank you
Thank you.
everyone.
Thank you.
It was a very
Thank
nice.
you.
It was a
And
very
happy
nice.
Teachers Day.
Thank you, everyone.